Okay, so the fire drill's over. Now I gotta try to finish this video. I don't even remember where I was, but we want factors of this last value to add to be the middle value. So I can see right here that 2 and 14, you can put those together to get 12. Remember, I want a negative 12, so that means my 14 needs to be the negative 1, and my 2 needs to be the positive 1. Now, if you were to FOIL this out or multiply it, then you would get x squared, negative 28, and then your outside would be negative 14x and positive 2x, which would give you negative 12. So to solve it, to go all the way through the solving process, remember when I just told you we want it to equal 0. So we set this whole thing equal to 0. And the product, the 0 product property states that in order for something to multiply to be 0, one of the factors has to be 0. So either this whole thing has to be 0, or this thing has to be 0. If this is 0, then x would equal negative 2. And if this equals 0, then x equals 14. So those are your two solutions, negative 2 and 14. Let's do another one. All right, f of x equals x squared minus 14 plus 48. So we get our parentheses ready. We know that's going to be x. 48, so it's a positive. So we know that either these are both going to be positive or they're both going to be negative. In order to get this positive number over here, you have to have two positives or two negatives. This is negative, which means these are both going to be negative, because the only way to add to get something negative is to have a negative value in it. So let's, okay. The factors of 48 are 1 and 48, 2 and 24, 3 and maybe 16, 4 and 12, 5, 6 and 8, and then we're done. So we want to get to negative 14. When you look at the factors, you can see that we have two options to get to negative 14. No, that doesn't work. One option to get to negative 14. 6 and 8, and we plug those in. So this would be a negative 6x and a negative 8x, which would give you negative 14. And then to solve, you would set them equal to 0. This would equal 6, and this would equal 8, so that means my answers are 6 and 8. Okay, let me show you some more. All right, this example, we look at it, and you should notice that the value right here is not just x squared. We have a number in front. So first, let's see if we can factor anything out. And what will go into all of these is a 4. So we are going to factor out a 4, which means we're going to divide them all by 4. When I say factor out a 4, that means divide them all by 4. So we're left with x squared. This would be a negative x, because 4 divided by 4 is 1. And this would be a 12, because 48 divided by 4 is 12. Now I have something that looks a little more manageable. You bring your 4 down, and then get your two parentheses. And we're going to start with x. And this last one is a negative, so that means we're going to have one positive and one negative. One positive, one negative. Now I need the factors of 12. 1 and 12, 2 and 6, 3 and 4. Which factors would come out to give you a negative 1? This is a negative 1 right here. So when you look at the factors, we can get a 1 using 3 and 4. Since we want a negative 1, that means our 4 needs to be negative, and our 3 needs to be positive. To finish the solving process, we set them equal to 0. And we get x equals negative 3, and x equals 4. So those are your two solutions. Let's do another one. F of x, again, the thing you want to do is you want to factor out what do they all have in common. And they all have a 10 in common. So let's factor out a 10. So we divide x squared 50 divided by 10 is 5. 60 divided by 10 is 6. We go ahead and set up our parentheses. And then we look for the keys. This is a positive 6, but this is negative, which means we need 2 negatives. And our factors of 6 are 1 and 6 and 2 and 3. Well, we need to get a negative 5. So when you look at this, we can get to 5. However, there's only one way that will work to get to negative 5. We could do 6 minus 1, but you can't, then they both be negative. So negative 6 and negative 1 doesn't equal 5. But we can use 2 and 3, and a negative 2 and a negative 3 does equal negative 5. So you set them equal to 0, and then x equals 2 and x equals 3 are our solutions. All right, so you try E, and then pause the video, you try E, and then press play when you're ready to hear the answer. All right, so we're going to factor out a negative 2. That gives us x squared. Now this is where it gets confusing. Negative 6 divided by negative 2 is going to be a positive 3x. And 56 divided by negative 2 is going to be a negative, I think 28. Let me double check. Yep. So I'm going to put x and x. I know this is a minus, I know it's going to be a minus and a plus. So I'm going to use, to get to 3, I'm going to use 4 and 7. 4 and 7. This is a positive 3, so that means my 7 needs to be positive, my 4 needs to be negative. And x is equal 4 or x is equal to negative 7. All right, I hope you got that one correct. Now let me show you one that's just written a little differently. It's the same thing, you just have to kind of manipulate it a little bit. Instead of being equals f of x, we have equals 12. Well, we want it equal to 0. You always want your quadratic equation to equal 0. So we're going to move this over by doing minus 12. And I get 5x squared plus 4x minus 12 equals 0. Once you do that, then you can go on through to the factoring process with your parentheses. Now this one is done a little differently, and I want you to star that because of the fire drill, I'm running out of time, and there's no way for me to finish teaching you this and get to everything. So we're going to pause right here just for a moment, and all right, I want you to get down this. So make sure you copy this down, the special cases. Pause it, copy this down, and then I'm going to pick up right here and I'm going to work it out. So this is a perfect square trinomial. The way you notice is this first one is a perfect square and this is a perfect square. We look at this middle section. It follows in line with this one. So we know that our answer is going to be x minus 3 squared, because the square root of 9 is 3 and the square root of x squared is x. Because it's this minus 1, I know it's going to be here. Therefore, when you set it equal to 0, you only are going to have one solution because it's the same binomial, x minus 3, x minus 3. In this example, we have this is going to be 4. This is going to be x because the square root of x squared is x, the square root of 16 is 4, and because of the plus, it's going to be plus. Now I have factored it. I used the special perfect square trinomial. X plus 4 equals 0, so x is equal to negative 4. Again, you only have one solution. I know this is quick. We'll go over it in class. All right, here's another special case that I want you to get down. pause it, copy this down. If you have a difference of perfect squares, so that means your first term is a perfect square, your second term is a perfect square, and it's a difference of perfect squares. Then to factor it, when you're going to factor it, it's going to look like this. So here we go. This is a perfect square, 9x squared, and a perfect square of 4, and a difference. So that means the square root of 9x squared is going to be 3x, and then the square root of 4 is 2, and like the rule over here says, you have one positive and one negative. To solve this, you would still let them equal 0. And you would get 3x equals negative 2, and x equals negative 2 over 3. This one you would get 3x equals 2, and x equals positive 2 over 3. Hopefully it makes sense to you why the solutions are opposite values, the same fraction but opposites. That's because we had one positive, one negative. Let me show you this one. We have a difference of perfect squares, but first we need to factor out an 8. Remember, we factor out an 8, and we get x squared minus 9. Then this is a difference of perfect squares. So we know we're going to have an x, square root of 9 is 3, and because of our rule, we're going to have one positive, one negative, which means x is going to be 3 or negative 3 for your solution. Alright, so this one right here, I want you to try that one. It's a difference of perfect squares, so see if you can figure out what the solution of this one is going to be. And the ones we skipped, F, G, H, we will come back to at a later date. So I know it's a lot. Copy down the notes, come in with your questions, and I will be happy to answer them.